yeah, if you would like some help trying to create a standalone service or some ideas about architecting your system to allow you to build up these independent services, that's what I'm here for. So my name is Mando Escamilla. I work for a company called Union Metrics. Union Metrics, like I said, does social media analytics. We take a lot of data from various social networks, including Twitter and Tumblr, and do deep dives on that data for our customers, right? And the best way that we've found to kind of architect this big system is to apply the micro philosophies that you use when building your software to the entire system at large, right? So solid principles, single responsibility principle, like these kinds of things don't just apply to when you're writing your code. They apply also to when you're architecting out your big system, right? So coming up with a kind of service-oriented approach allows us to it gives us a better way to apply those principles. So the first step in doing this is to identify. My kids really like the joke. I was kind of hoping you guys, this is fine. So you want to identify places in your application where developing a service is a good idea. So those kinds of places are places that are going to provide reusable data or reusable kinds of actions, right? If you have different areas of your application, different areas of your architecture that are going to be looking for data from one place, right? Or you have something that does something really well, and you have two different places or more places that need that thing done, it's a pretty good candidate for a service. Anything that provides data, anything that generates reports, anything that consumes and then creates this thing, right, is also a pretty good candidate for building it as a service, as opposed to setting it up in a monorail, right? So once you identify kind of where you want, or something that you think would be a good service, or might be a good candidate for a service, right? The next step that we do at Union is we write a spec. And these specs are, well, they're pretty specky, actually. It's I've been doing this for a long time, writing software, and I've seen a lot of, I've seen some things. I've worked at places that have been super top-down design, right, where you have like an architect who sits in a room for like 3 months and then comes out with stone tablets like Moses and says, this is what you build. And then I've worked on teams where everyone's like, sweet agile bro, don't tell me what to do. When we're writing services, we found that you can't overthink the problem and you can't spend too much time coming up with a decent, solid spec for it. So this is a little bit of one of our specs. I'm going to talk a little bit about a service that we wrote called Spectator. And what Spectator does is gather various bits of information about things on social networks, right? In this case, we're talking about observing an entity, right? And the kind of components of it are a service, which, say we'll talk about Twitter, and an entity, so like a Twitter user or Twitter account. So yeah, what I really want to show is the kind of the shape of the spec, right? So we have the URI, and we have some basic information about how this action should act. And we have the parameters, like I said, a service and an entity. And we have the request body that you're going to post to the observer's endpoint. And we require that there is a name, and then we have an optional credentials hash. Some services will require authentication, right? Like Twitter, you have to send it OAuth information. Others don't, so that's why it's optional. And down here, I apologize, I ended up getting cut off, but we have our response definition, right? So we say that there's no response body back from this endpoint, and the the 3 HTTP status codes that it's going to return, right? So I have a 201. If it works, a 409 if it was already there, and at the very bottom, it's a 403 if the credentials were bad. The basic idea, right, is we have this spec, we have this design, we have this contract, for lack of a better term, right? And when you have a solid contract like this, it becomes really easy to write the client and the server, right? You define this nice, stable interface. So we move on to the client for now. We don't start writing the service yet. We write the client first. And one of the reasons we do that is because it allows us, or rather, it forces us to focus on error handling first. Before you ever write the service, before you ever deploy, anything like that, we make sure that we handle the case where the service doesn't exist, right? Or the service has gone away, or the service is providing bad data, right? And it's really easy to do if you write the client first because the service doesn't exist. This is what the screen looks like when Spectator is down. I wrote Spectator, so sometimes we see this more often than I like, and when we do see this, I get an email. But you see that it doesn't break the page, doesn't give you a 500. What it does is it gives you an empty graph, right, and some NAs, and a little flash message at the top. This is what happens in production now. This is also what happened when we first started developing Spectator, right? So the nice thing about this is, even though we knew that we wanted to put Spectator-y stuff in here, there were other people obviously working on other areas of this screen, and they didn't have to write their own like stub data or handle that case before, when Spectator hadn't been finished yet. So once we've done some error handling, we move on to a very basic kind of connection config. A lot of this stuff is super basic, right? This, as an aside, this stuff isn't really science. It's just it's not that hard. And I work with some really, really smart sciencey folks. I'm not one of those. And so these are just lessons that we've learned over time on how to easily and cheaply get these services running and keep them maintained. This is our super cheap ghetto configuration style. We have a YAML file that looks a whole lot like the database.yaml. We have a initializer that throws that stuff into a config, Rails application config. And then at the bottom you see the client sketch, which just loads up the configuration in the initial line. So, one thing you'll see here, right, is this line, include Union Adapter's HTTP clients. That is the way that all of our HTTP clients talk to HTTP services, right? It's super important to us to have unified access because we didn't for a while, and it was really terrible to have, 6 or 7 different HTTP clients all acting differently, behaving differently, handling errors differently. So we wrote a really simple one that everyone could use. And again, I apologize for the size of the code, but I just kind of really want to give you the idea that it's not that big of a deal, right, to do this. This is a really, really simple client. We handle sending off the requests with HTTP party because it's awesome, and we have some basic handling of the responses based by HTTP code, and we have a special response error exception that gives us information about the HTTP request in the event that there was an exception, right? And I had to put the end at the bottom, and I apologize for that. Then once you have the unified access, right, you kind of have to just, write the client itself. So Spectator gathers data, and it also needs to be updated with credentials. In this case, from our Rails stack, we didn't use a Rails stack to gather the information from Spectator. It was kind of write only from our Rails application. Another service, reporting service, is what talks to Spectator to get the actual data. So all we were really worried about was providing credential information to Spectator. So that's all the client does, right? We haven't exposed the full functionality of Spectator to Rails because it didn't need it, and we didn't want to overwhelm the developer who has to use this client. These are the only 3 methods that they need to worry about. And modified credential is super simple. It does the talking to our unified access client via get response. And this part is really cool, get local response, but we'll talk about that in a minute. Maybe wondering about tests. For this, for Spectator specifically, we didn't go with a kind of test-driven, test-first style. Usually we do. In this case, it was the client was very much a sketch. We were still kind of fleshing out exactly how we were going to use Spectator in the Rails app. So we just kind of started sketching out the client, and once we settled on the way that it was supposed to behave, that's when we started writing our tests. Again, super simple, right? WebMark is our friend when we're testing these things. We use something that just stubs out what we expect to see in the request, right down at the bottom. And we start testing the behavior, right? We want to make sure that when we add credentials that it sends an actual post, right? Because that's part of the spec. More importantly, we wanted to make sure that any exceptions that were raised, right, were logged and caught. Spectator isn't a tier 1 service, like we call them. Tier 1 services are services that are like stop the world, like this should break everything because we're going to potentially introduce bad data or something like that, right? Spectator isn't like that. Spectator is something that can kind of fail. We can backfill data afterwards and stuff. So we don't want the users to be super, we don't want the users to be put out if Spectator isn't around. So once we've got this in place, we can start working on our server. When we start building the Spectator service itself, I experimented with this thing that I call the demo interface, right? And what that means is it's basically a fixture of data, right? So, like I said, Spectator gets, in this case, follower counts for Twitter, right? So, the service that was consuming data from Spectator was ready to consume it before I had finished writing it. So I put in this little shortcut up at the top where you see return trend fixture if params debug is set. So all that service has to do when it queries this endpoint right here, the trend endpoint, is set that debug flag, and it immediately shortcuts any logic and returns a JSON stanza, just a hard-coded JSON document, right? It doesn't do anything, right? But it saves us some time, and it allowed the person who was writing, the consumer of this data, right? It gave them a chance to see what the shape of the data was and what to expect and what proper values were, and they could move on with what they needed to do without being bottlenecked by the guy who was writing Spectator, which was me. So we also think that command line tools are important for this stuff. They don't have to be fancy. This is probably the worst command line interface for a service ever written. It literally just shells out to curl, right, with hard-coded little hashes and stuff, and my account name and all sorts of awfulness, right? I didn't want to spend a lot of time on it, right? But I also didn't want to have something where I had to, boot up Rails or to test this, to observe kind of the behavior, right? So don't feel like you have to build a full-on, fully tested command line when you're building these kinds of things, right? A simple shell script, in this case a little Ruby script that shells out, it's fine. No big deal. Health and monitoring are extremely important when you're building out a distributed architecture, when you're building out these little services. Our operations guys hate it when they can't easily figure out if a service is doing well or not doing well. God forbid if it goes down. So this is what Spectator's health check looks like, right? We check the things that are important to Spectator. Spectator really, really, really needs rescue, and it really, really needs a database. So we make sure that every time we check, every time we hit health check, we check both of those things, and then return 200 with the JSON body, or return a 500, and then I get paged in the middle of the night. So on the service side, since we have this really, really awesome spec that we spent some time thinking about and designing, right, it's the perfect candidate to do, to build in a test-driven manner. And so that's what we do. We have, in this case, one of our tests, or one of our test files. And you'll notice I just kind of cheat, and I paste the entire spec for that method right above the tests that I'm building, right? Eventually, I'll go back and delete that, right, because it tends to get out of date. But it's nice to have it there when you're building the test, right? And sometimes I'll leave it in, and so in the event where the spec drifts, right, I can go back and say, oh, this was obviously an old version of the spec that these tests were written against. But yeah, basic tests. Rack test is your friend. This was a Sinatra app that eventually grew into a Rails app. I mean, it's not Rails, it's still Sinatra, but it's kind of like I wrote Rails again with Sinatra again. You'd think I'd learn that lesson after like the 5th time I did it, but nope. Every time I think this time's going to be different. Never is. So now we have a functioning service, and we have a functioning client, right? Now they need to talk, right? We need to integrate them. We need to kind of get the ball rolling, get this out to our customers, and that's kind of how we feel every time we try to do that. We don't really have a really good story around a solid process for doing this kind of integration. It's just hard work. This is where the really, really, really hard work is from a development standpoint. And sometimes there's no good answer other than you just kind of have to work. One thing we do that helps is we have these little shortcuts that allow us to have our clients return local data as opposed to being forced to go out to talk to the service, right? Before we saw this little shortcut that, called getResponse, which is the way that everything talks to our HTTP services, right? But if you send getResponse a flag called, I think in this case it was stub, we get shortcutted over to get local response. And all this does is it goes down and looks for a file on the file system, right? So it doesn't have to, it completely short circuits the entire talking to the service itself and returns local data. The best use for something like this is for viewing production data locally, right? Being able to reproduce production data locally without having to do things like get a copy of a production database or get a copy of production Redis, right? We can say, this service provides this JSON data in production, right? We can go hit that endpoint, save the JSON file, store it locally, suck it up and see it without having to get all of that data and mishmash of stuff onto the local developer's box. They can immediately see what's happening on production locally and then make whatever changes they need. Super, super useful. So now we've got a service up and running. We have a client written. They're talking. They're happy. Everyone's wonderful. So what are the risks for building out a system like this, right? There's a lot of them. Development environments are a big risk, right? When you have an application, a Rails app, that requires 5, 8, 10 different services running, you kind of have to have all those things running in your dev environment in order for you to get work done. That's a lot of overhead. That's a lot that has to be running on your machine. That's a lot to manage. And we fall down a little bit, honestly, in this area, right? We're a super, super small team, right? So we don't have a lot of time to devote to doing experiments with things like Docker or Vagrant, right, which are obviously the right approach for this. So we just kind of wing it right now, honestly. But there are better stories now for things like this, especially doing things like Vagrant and Docker-based Chef integrations, right, which will allow us to kind of use the same things we do to deploy and build out servers in production to do that locally. But it's a challenge. Context is another huge risk with this stuff, right? If you have a Rails application that requires 5 different services running, you have to know that you need to have 5 services running, right? And you need to know where that data is coming from, right? Data for screen X is coming from service Y, and so on and so on and so on. It can be confusing. It can be easy to get lost in the weeds in a situation like this. It's one more thing that you have to worry about as a developer. So that's an actual real, honest-to-goodness risk. Operations is another big risk. Every time we decide as a team that we need to build a new service, right, you can visibly see our operations guys get sadder and hate their lives more. So we try not to do it too often, but when it's the right approach, it's the right approach. So more services means more problems, right? It means more things in production, more things you need to monitor, more things you need to make sure are up and running, more things that need to behave appropriately and perform. So that's a concern, right? If you don't have a good kind of ops story, right? If you don't have a solid team or you don't have that stuff under control, moving into a direction like this where you're building out services might not be a good time for that. There's also a lot of rewards, right? I mean, there's a reason why we do it, and there's a reason why a lot of places do it. Small deploys are a huge reward, right? You don't have to worry about the case where you have to build out and deploy your Rails application in order to make small changes, in order to dark ship things. You can burn in services on their own and let them collect data in the background without it ever impacting customers until you can flip a switch in your Rails application and start consuming that data. You don't have to worry about pushing out big swaths of code. You can make small, tiny, quick little deploys easier, I think, in kind of a service-oriented manner. You can experiment a lot more, right? I wrote Spectator in Ruby and Sinatra. It could have been a Node app. It could have been a Clojure app. It could have been written in whatever, right? It just has to talk HTTP. I mean, this is kind of a double-edged sword, right? Because you do run the risk of having that one Clojure guy in the corner. He's the only guy who can work on this one particular service, and no one else knows anything about it. So you kind of have to weigh that. But as software developers, right, sometimes we are the happiest when we get to kind of play around and do things with new technologies or in different ways. And so having different services that you can work on and experiment with, either different languages or different styles or whatever, right? It's a good way to keep that developer happiness up. It's also a really good way to shoot yourself in the foot. So, like I said, parallel work is the huge win for me, right? We can have someone working on a client and a server at the same time, multiple people working on each if you need it, right? It really does speed things up. You get this ability to have these awesome feedback loops on the design and customer-facing side, right? If you do things like provide these shortcuts to load local data, or you have this demo fixtured out interface, you can immediately start seeing what this data is going to look like without it actually having to be done yet, right? So your designers or the person who's responsible for developing the user experience, right, can see that stuff immediately and start playing around with it while the actual service and logic is being built, right? So it's a lot of fun to work this way, right? It's nice to be able to get stuff out quickly, and it's a huge benefit. Like I said, I work for a company called Unitmetrics. We do this stuff all day, every day. I love it. On a personal note, it's the best job I've ever had in a series of really, really awesome jobs. We're a small team. We're co-located. We have an Austin office and a San Francisco office, and all of engineering is based in Austin. So if this kind of stuff sounds interesting, if collecting, awesome metrics about social media stuff sounds interesting, come by and talk to me afterwards. Yeah, awesome. Thanks, everybody.